So let's just recap really quickly what we have so far. So this is called a frequency distribution table. These are called classes. There's 1, 2, 3, 4, 5, 6 classes, and we added a 7th. And these are called the frequencies for each class. So there are 5 employees that have served 1 through 5 years. There are 20 employees that have served 6 to 10 years, so on and so on. And so we found the total number of observations by adding up all the frequencies, and it turned out to be 68. Then we found the number of classes just by adding these. So that was on 1, 2, 3, 4, 5, 6 total classes. And then the way you find the class width is you subtract the lower class limits. So these are called lower class limits. 6 take away 1 is 5. You can also do 11 take away 6. You can do any 2 that are consecutive. And that's how you find the class width. Uh-oh, I think it froze. I'm going to move over to the other room because I think I'm too far from the router. And that's why it's not really, the connection is bad. But if I get closer, the connection will be better. All right. Here we are. So let's see if it helps. There we go. All right. And then the next thing we did was find a midpoint of the second class. So the way you find midpoints is you just add the lower class limit to the upper class limit and divide by 2. In this case, I wanted the second class, so we did 6 plus 10 divided by 2, and we got 8. So that would be the midpoint of this class. And then the modal class, that just means that the class that has the highest frequency. So I'll write that. Highest frequency. And the class that had the highest frequency in this case was, the highest frequency is 25, and the corresponding class was 11 to 15. All right, the class limits of the next class, if there was an additional class, the way we found that is we added the class width to the lower class limit. So 26 plus 5 is 31. And then 30 plus 5 is 35. And that's how you find the next class. So that's pretty much where we left off. So now let's go to this next example, which states the following frequency distribution is a weekly earning for a sample of 100 employees. So, all right, so that means that all of these have to add up to 100. These are the classes. Find the class width. So we found that by subtracting 348.5 minus 199.5, and that's how we got 149. The midpoint of the third class, you take the sum of these two numbers, you add them, and then you divide by 2. So that's what we did here. We added them, divided by 2, and got 571.95. The class limits of the next class, if there was an additional class, is we take the class width and we add it to the lower class limit. So if you add these two numbers together, you're going to get 944.5. And if you add 149 to the upper class limit, you're going to get 1093.4. All right, so that's pretty much what we learned last class. Now that is it for number 3. Let's look at the next one. Numbers of keyboards assembled by the 20th Century Electronic Company for a sample of 25 days are as follows. So that means there's 25 data values, and what they represent is the number of keyboards assembled by this company. So this, of the 25 days. So maybe on one of the days they assembled 45 keyboards, on the next day 52, 48, so on and so on for 25 days. Use this data to construct a frequency distribution. So this time they don't give us the frequency distribution, they only give us the data, and we are expected to create a frequency distribution table. And luckily for us, they give us the first class. All right, so it says here we are given the first class is 42 to 45. Therefore, the second class must start at let's see, how do we determine if we don't know the class width? That's interesting. Oh yeah, that was my fault. So to get the next one, the next number after 45 would be 46. So the next one would have to be 46 through, and then remember, well, I'll just put it right underneath 46 through something. So you just take the number that comes after 45, that would be 46, and then you find the class width by subtracting. So 46 take away 42 is equal to 4. So that's your class width. All right, so all right, and so the way you get this number is you add 4 to 45. So 45 plus 4 is 49. 49. So now you see that these two, the difference is 4 and the difference is 4. So that's how you can check your answer. So that would be our answer right there. That would be the next class. All right, then they say find the class width. Oh, okay, well, we already did that step. The class width, you find it by doing 46 minus 42, which is 4. We already did that. All right, to find the upper class limit, we already did that as well. The upper class limit, you just add 4 to 45. 45 plus 4 is 49. All right, so that's how we found the upper class limit. So the second class is equal to, I'm just going to write that here. I guess they want us to show the math. So 45 plus 4 equals 49. That's how we were able to find the upper class limit for the second class. All right. Find the other classes using a similar technique. Fill them in the chart. All right, so let's start with the first class, which we already have. It is 42 through 45. And then the second class, which we already found, was 46 through 49. Does anybody know how to get the third class? Well, you just take the class width and you add it to the lower class limit. So 46 plus 4 is 50. So, and then you do the same thing to 49 plus 4 is 53. And you just keep doing that. 4 plus 50 is 54. Then you do the same thing. 4 plus 53 is 57. And then you keep going until, do they tell us how many classes they want? They should tell us. Let's see. No, they don't tell us, but that's okay. All you have to do is look for the largest number. Anybody see what's the largest number you see here?
I think 56.
Yeah, I see 56 as the largest. That means we can stop because the largest number, we don't need to go any bigger because 57 is already bigger than 56, so we can stop. So, all right, that's how you determine how many classes you need. You just keep going until you reach the largest number and then you can stop. So now we have to figure out the frequency for each class. So let's go through the list and see how many of the numbers fall between 42 and 45. So 1, 2, wait, uh-oh, that's weird. I don't know why they did that. Usually the smallest number is when is where you start. See how they started at 42? They should have started at 41. I think that was a mistake. Let's just change this to 42, because I think they made a mistake. So let's just do that, because that doesn't make sense, because otherwise there's nowhere to put that number. 41 doesn't fall anywhere. So you have to choose your smallest number to be your lower class limit. All right, so we'll just pretend that that was a mistake. So that would be 1, 2, 3, 4, 5, 6. Did I get them all? I think so, right?
Yeah.
All right, so it looks like there's 6. 1, 2, 3, 4, 5, 6. So we'll say 6 here. All right, let's move on to the next class, 46 through 49. So 46 through 49 would be 1, 2, 3, 4, 5, 6, 7, 8. I think that's all of them. Yeah, that looks like it's all of them, right? So that would be 1, 2, 3, 4, 5, 6, 7, 8. All right, so 8. All right, next class would be 50 through 53. So let's choose a different color. Okay, so how many of those are going to be between 50 and 53? There's 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, I think that's it, right? And then finally, 54 through 57. Okay, 54 to 57. 1, 2. There's 2.
2.
All right, let's add them up just to make sure that it is equal to the total number, which it should be 25. According to them, there's a total of 25 days. So the total should be 25. Let's see if we did that right. 6 plus 8 is 14, plus 11 is 25. Yes. That is our total days. All right. So that's how you fill out a frequency distribution table. All right. All right. Let's move on. Oh, there is nothing else here. So we're done with that section. All right, so let's see what the next section is. Let me just look at the modules to double check that we are supposed to do another one. I'm pretty sure we are. Week 12, we're supposed to go up to 12.3, and this is 12.2. So yeah, we do have one more section to cover today. So here it is. It's section 12.3. So on the notes, it'll say 13.5, but we're going to change that to 12.3.
Professor, there was another one there. Just throw that one out.
Oh, was there another one? Let's see.
They said
Uh,
continue notes of 12.2.
12.2. My 12.2 starts here, and then it just goes here, here, and then here. It
Okay.
just goes up to page 4.
Okay.
This one is page 4 again, so that one doesn't count. It's the same page.
Okay.
Yeah, so now we are here. So this one is called the measures of tendency. Oh, sorry, measures of central tendency. So this is where we're going to talk about mean, median, mode. Those are the three measures of tendency, the measures of center of tendency. So let's look at what these definitions are. A value at the center or middle of a data set. The center by weight would be the mean. Right. And then the next one says center by position. That's going to be median. So let's look at median. So that would be, all right, median, yes. All right. Now we got the next one, which says center by popularity. That's going to be mode. So that's like the most popular one is called mode. Okay, and then the last one says the average of the smallest and the largest value. That's called the mid-range. Mid-range. So that there's actually four measures of central tendency. All right, so let's look at the definitions. For the first one, the mean, the measure of center obtained by adding the values and dividing by the total number of values. So in statistics, they call that mu for the population and X bar for the sample mean. So here are the two notations. The mu looks like it's a Greek letter, it looks like a U, like that. It just has a long tail in the front. The X bar, that just looks like this, X bar. So that's sample mean. This is population mean. All right, and the formula is going to be the sum of all X divided by N. So this Greek letter, sigma, that means sum. So the sum of all the data values divided by however many data values there are. So we will definitely do some examples right now. So they give you the definitions. This is the sum of all data values. And then N is the number of data values in the sample. All right, the next definition is called the median, and it's a value that lies right in the middle of the data set. But it has to be arranged in ascending order. So from smallest to largest, you have to arrange the data values from smallest to largest, and then you take the one right in the middle. That's called the median. All right, to find the median, first sort the data values, arrange them in order of increasing, smallest to largest, then follow these two procedures. If N is odd, so if you have an odd number of data values, then you just take the middle term. But if N is even, then that means you have to take the two middle terms and find the mean. That means you have to add them and divide by 2. So for example, let's do an example. All right, I will do this example right here. Let's say you had 10, 14, 2, 9, 7, and 20. So is that an odd number of values or an even number?
I have odd and even.
Oh no, the number of values. How many values are there?
Oh. 6.
6. So that would be even, right?
Yeah.
So first thing you have to do is you have to write them from smallest to largest. So that would be 2, 7, 9, 10, 14, and then 20, right? Yeah, so that's from smallest to largest. And then you take the 2 that are in the middle, that would be these 2. And then you have to find the mean of the 2 middle terms. So you have to add them and divide by 2. That's how you find mean. So let's add them and divide by 2. So 9 plus 10 divided by 2 is 19 divided by 2, which is going to be 9.5. 5. So that's how you would find the median when you have an even number of data values. First, you arrange them from smallest to largest. Then you take the two middle ones and you find the mean, and that's how you get the median. All right. So we're going to get more practice because there's more examples here.
What is that called? The answer at 9.5, the medium?
Median, so that would be MEDIAN.
Okay.
Yeah. All right, let's look at another example. Example number 1 says the following data represents travel times in minutes to work for a sample of 7 employees. So we know that there's 7 employees. All right, so let's count them. 1, 2, 3, 4, 5, 6, 7. So now let's find the mean. So remember the mean is X bar, and it's the sum of all the data values. That means you have to add them all up and divide by how many there are, which is 7. So 23 plus 36 plus 23 again, plus 18 plus 5 plus 26 plus 43 divided by the number of data values, 7. That's going to be the answer, whatever you get. So I'm going to get my calculator and find out what that is. All right, did anybody get
108.714.
what did you get again for the sum?
So we add them all up and divide it by 7.
Yeah,
Let me see, did I get the right number? 108.714.
not quite. Let's add them again. First, let's add them and then we'll divide.
Oh, I didn't do them all. I'm sorry.
Okay. So I'm getting 174 divided by 7, which is 24.85. 85 will round up to 9. So I'm just going to round it to 1 decimal place. So that would be the mean. All right, approximately 24.9. All right. So now let's find the median. All right, so now we'll do the median. All right, so first for median, we have to arrange these from smallest to largest. So the smallest is 5. Then we got
18.
18. We got 23. 23 again. 26. 36. 43. All right, is there an even or an odd number of data values? There's 7 of them. 7 is odd.
Odd.
Yeah, so when there's an odd number, you just take the middle term. So the middle one is this one, because there's 3 to the right, 3 to the left. So this one is the middle one. That is the answer. 23 is the median. All right. So that's how you do the two, mean and median.
So when it's odd, you just put 23.
Yeah, whichever one is right in the middle.
Okay.
But if it's even, then you have to take the two middle ones and then find the mean. So that's the difference between even and odd number of terms. All right, here's another one. So this one says that suppose the startup company hires a new employee. The travel time of the new employee is 130 minutes. So now we have a new data set. So now let's do the mean. So we do the same thing, X bar again. Do the same thing that we did earlier, just add the new number. This time, what are we going to divide by this time?
8.
8, yeah. So you can just take 174 and add 130 to it because we already know that the sum of these numbers is 174. So you don't have to add them again. All you have to do is add 174 plus 130. And I'm getting 304 divided by 8, which is I'm getting 38 minutes. So that's the mean travel time for the employees. All right, now let's look at the median. So same thing, this time we have to write them from smallest to largest again. So it's going to be the same list over here, just add the 130 to the end. I'm just going to copy it over. So I took the same list that we had over here, and I just added 130 to it. All right, so now we have 8 data values. So now we have to take the 2 middle ones. So which 2 would be right in the middle? I think it's going to be these 2, because you have 3 to the right and 3 to the left. That means that those 2 are the middle ones. So you have to take the mean of those 2. So you have to add them and divide by 2. Oops. So it's median is equal to 23 plus 26 divided by 2, which is 49 divided by 2, which is 24.5. All right, so that is going to be the median. All right. So let's see, it says here, how does this new data value impact the value of the mean and the median? So let's see how it impacts the mean first. So without 130, the average or the mean was 24.9. With 130, it's 38. So as you can see, it increases a lot because 130 is called an outlier. That means an outlier that's a number that's far away from the rest of the data set. So since 130 is a lot farther away from the rest of the data, that means it's going to impact the mean a lot. As you can see, it went from 24.9 to 38. So I'm just going to say it impacts the mean greatly. And what about the median? Is the median affected greatly or not so much?
Not so much.
Not so much. It hardly moved. It just went up 1.5 units. So as you can see, it did hardly move. So the median does not get impacted that much. The median does not get impacted as much. All right, so here's a summary. The summary is going to say, all right, let's see what the summary says. The numerical summary of data is said to be resistant if extreme values, such as very large numbers or very small numbers, relative to the data do not affect its value substantially. So something is called resistant if it's not affected by extreme values. Like 130 is considered an extreme value, it's an outlier. So 130, so we would say that the median is resistant, but the mean is not resistant because the mean was impacted greatly and the median was not impacted that greatly. So mean is sensitive to every data value. One extreme value can affect it dramatically. So the mean is affected. It's sensitive to extreme values, and the median is not affected by extreme values. So that means it's resistant. So median, yeah, so there it is. So that's the difference between the median and the mean. The median is not affected by extreme values, and the mean is affected dramatically. All right. So we say mean is resistant. No, I'm sorry, mean is not resistant. And median is resistant. All right. All right, let's move on. Okay, so that is that. All right, now for mode. Mode is the most popular value. So having two modes is basically the one with the highest frequency of occurrence is called the mode. So having two modes, that means it's bimodal. Bimodal. For example, well, we'll do some examples right now. And then when each value appears only once, that means there's no repeats at all. That means there's no mode. Because they all have the same frequency, so therefore there's no mode. All right, so let's look at example number 2. This one says, find the mode. Which one occurs the most of all these numbers?
27 and 55.
Yeah, those two occur 3 times each. So those two, that means we have bimodal because 2 of them have the same highest frequency. So there's 2 modes, 55 and 27. So that would be bimodal, both 27 and 55. All right. All right, what about the mode for the next one? There are no repeats, right?
No.
So therefore there is no mode. No mode. All right, the mid-range. The mid-range is the value, the midway between the highest and the lowest value. So you just add the highest value plus the lowest value and you divide by 2, and that's how you find the mid-range. So let's find the mid-range for this next example. Following are measured amounts of lead in the air. Find the mid-range. So you have to take the highest plus the smallest. So what's the highest here? Let's see, 5.4, right?
Sure.
And then the low would be,
0.42.
yeah, that would be your low. All right, so the mid range is going to equal to 5.4 plus 0.42 divided by 2. So that's gonna be 5.82 divided by 2, which is 2.91. All right, so that would be your mid-range value. All right, let's look at number 4. Samuel consumed 2,103 calories of food on Monday, 2,335 calories on Tuesday, and 1,832 calories on Wednesday. In order for Samuel's average calorie intake to equal a daily average of 2,100 calories, how many calories of food must he consume on Thursday? All right, so they tell you the average, the mean, right? And average is kind of another word for mean. So they want the average or the mean to be 2,100. So there's, let's see, okay, so in order for him to average 21 a day, you have to add up Monday, Tuesday, Wednesday, and Thursday, and then divide by 4 and make it equal to 2,100. So that would be 2,103 for Monday, 2,335 for Tuesday, 1,832 for Wednesday. For Thursday, we don't know. It doesn't tell you. It says how many calories of food must he consume on Thursday. So we're going to call it X, since we don't know. And we want the average to equal to 2,100, because that's what they tell us here. All right, so there's 4 days, 1, 2, 3, 4, Monday, Tuesday, Wednesday, Thursday. That means we have to divide by 4. So we need to solve for X. All right, so that's the question here. We have to solve for X. So what you want to do first is you want to add up all these numbers here. So let's add up those numbers first. All right.
6270.
Yeah, you should get 6270. All right, so 6270 plus X divided by 4. So the way you solve for X, you have to get rid of the 4 somehow. Does anybody know how to get rid of the 4? Well, you have to multiply both sides of the equation by 4. So if you multiply both sides of the equation, the 4s are going to cancel. So 4, 4, that's why we did that, to cancel out the 4. And then we're going to be left with, I'm going to have to write it over here now. 6270 plus X equals 2,100 times 4 is 8,400. So I just multiplied 2,100 times 4 and I got 8,400. And now to solve for X, it should be pretty simple. At this point, we just subtract 6270 to both sides. And you should get 2,130 calories. So that's how many calories he should eat on Thursday if he wants to average 2,100 per day. All right, so first you want to add up these numbers, and we did, and we got 6270. Then you want to get rid of the 4. The way you get rid of the 4 is multiply both sides of the equation by 4. That'll allow us to cancel. And then you'll subtract 6270, and that's how you get your final answer. All right, let's see. We've got a few more problems. So this is the last page here. So I think this would be a good time for a break. So let's take a break here. We'll come back in 15. So let's see, 11. It says, to get a C in Mrs. Forbes' statistics course, Nathan must average 70 on 4 tests. Scores on the first 3 tests were 69, 77, and 62. What grade or score must he receive on his last exam to pass this course? All right, so we're looking for an average. So we need to do 69 plus 77 plus 62 plus the last score we don't know, we're going to call it X, divided by how many exams there are. There are 1, 2, 3, 4 exams. And he needs to get an average of 70 to pass the class. So that's what we want the average to equal. All right. So we do the same thing that we did last time. We add up these three numbers. So let's add those up. That is 208 plus X over 4 equals 70. So now we got to get rid of the 4. We do the same thing we did over here, which is multiply both sides of the equation by 4 times 4 times 4, cancel, cancel. And now we're going to have, I'm going to have to write this over here again. 208 plus X equals 70 times 4 is 280. And now the last step is to subtract 208 to both sides of the equation. And that's how we end up with our final answer, which is a score of 72. So he needs to get a 72 on the 4th exam in order to pull off a 70% so that he can get a C in the class. All right, so that's how you would figure that out. An average of 80 is needed to get a B in the course. Is it possible for Nathan to get a B? So let's do the same thing, but this time instead of the average being 70, we want the average to be 80. So we're gonna do the same exact thing. And we want it to be equal to 80. So we multiply by 4. All right, we already know that this is going to be 208. It's the same thing. So it's going to be 208 again, plus X is going to equal to 80 times 4 is 320. All right, and now we have to subtract 208 to both sides. Oops. 208. X is going to equal to 112. So this time is that it's not possible to get 112 on the test. So because the maximum is 100% unless there's extra credit. So in this case, it's going to, is it possible for Nathan to get a B? In this case, we're assuming that there's no extra credit and the maximum is 100. So no, it is not possible. All right. Because 112 is greater than 100, and we're assuming that the highest grade is 100. If his lowest grade of the exam already taken is to be dropped, is it possible for him to get a B? So let's, all right, let's drop his lowest grade. The lowest grade is a 69. So let's, oh no, sorry, 62 is the lowest grade. So now you have 69 plus 77 plus one more exam divided by 3 this time, because now there's only 3 exams, and we want to see if you can get an 80. So we dropped the last test. I mean, sorry, the lowest test, which was a 62. So now let's do the same process. Let's multiply both sides by 3 this time. We can cancel the denominator. And now if you add these two numbers, 69 and 77, you should get 146 plus X is equal to 80 times 3 is 240. So if you multiply these two numbers, you get 240, and then subtract 146 to both sides. X is going to equal to, it's like 94, I believe. Yeah, 94. So this time it is possible for him to get a B in the class. He has to score 94 in order to get a B in the class. So if the teacher is generous enough to drop the lowest score, then it's possible for him to get a B. But if the teacher does not drop the lowest score, then it's impossible to get a B. All right, and I'm going to do the same thing for you guys. I'm going to drop the lowest test. So we'll see. That hopefully will help you out. I hope it does. All right, let's move on to the last page of the day. So this is called group data, frequency distribution, group data. All right, so it says the following frequency distribution represents the ages of Oscar-winning actresses. Find the mean of the age of Oscar-winning actresses. All right, so let's see how we can find the mean. So we know that 28 are between ages 21 and 30, 30 are between 31 and 40, so on and so on. So first let's find the sum of the frequencies. That's what this is asking for you to find the sum of that. So if you add these up, you should get getting,
76.
yep, 76. All right, so that means there's 76 Oscar-winning actresses that we're considering. The midpoint, so for the midpoint, remember how to do the midpoint? We add these two numbers and divide by 2. So I'll do that on the side. Midpoint, you're going to do 21 plus 30 divided by 2. That's going to be 51 divided by 2, which is 25.5. You have to do that for each one of these. So I'm going to save some time and I'm just going to write them out. That way we are able to get through the problems, but you guys can verify these on your own. Oops, that was the last one. Whoops. Let me. All right. So that's the midpoint. You just add them, divide by 2, add them, divide by 2, so on and so on. All right. This last column is asking us to multiply the frequency times the midpoint. See, X is the midpoint, F is the frequency. So in other words, just multiply these two numbers together. So 28 times 25.5 is 714. And then you do that for the rest of them. 30 times 35.5 is going to be 1065.
Excuse me.
And if you keep going, I'm going to write these numbers in. You can verify them on your own if you'd like. So we can save some time. So you just multiply those two, and that's how you get that. All right. And now they want us to add up this column. So now we have to add up all these numbers. So if you add them all up, you're going to get 2718. So I just added all these numbers together. That's what it's giving me. And then the formula for the mean of group data is going to be this divided by this. So we already have this and divided by this. So that's why they did this, so that we can only have to get these two numbers and divide them. So let's do that now. It's going to be 2718 divided by 76. And that is going to be approximately 35.8 years old if we round. So the average age of Oscar-winning actresses is approximately 35.8 years old, so almost 36 years old. All right. So this is called group data because we don't know the raw data. We don't know if this person was 25 or 26 or 27. We just know that 28 actresses fell within this range. 30 actresses fell within this range. So that's what they mean by group data, because we don't know the raw data. All right, so that's how you find it. And then this one's going to be the same thing. So we just have to do the exact same thing. The midpoint, if you add these two numbers, let's just do one example, and then I'll just fill in the rest. it's 1 plus 6.99 divided by 2. That's going to be 7.99 divided by 2 is 3.995. So 3.995. The next one's going to be 9.995, 15.995, 21.995. Now we have to find the frequency times the midpoint. So multiply these two together, you should get 21 times 3.995 is 83.895. Oops, 895. And if you do that for the rest of them, this 16 times this number, you're going to get 159.92. The next one's going to be 447.86, 285.935. So I just multiplied this times this, and that's how I got that. All right, and now as you can see, they're asking for the sum of this column. So if you add up these numbers together, you should get a grand total of 977.61. And now we have to add this column. I forgot to add that column. If you add that column, you're going to get 78. And remember, to find the mean, you just divide this number by this number. That's what this formula is telling us to do. So we're going to take 97761 divided by 78. And that's going to give us approximately 12.53. All right, so that's how you would find the the mean for group data. All right, let's see how this applies to GPAs. This is how you find GPAs, by the way. So the same formula works for weighted mean. So one of Mrs. Forbes' hardworking students took 5 courses in the fall. Find the GPA of the student whose grades are as follows. So statistics is a 4-unit class. That's called the weight. That's how heavy it is. The grade, she got an A. All right. All right. And chemistry is 5 units. That's even more units. And she got a B. History was a 3-unit class. She got a D. English, 3 units. She got a C. And then yoga, 2 units. She got an A. So the grade points that are assigned for an A is usually 4 points. A B is 3 points. A D is 1 point. The C is 2 points. And an A is 4 points again. And an F is 0 points. So that's always how the points work for grades. A is 4, B is 3, a C is 2, a D is 1 point, and an F is 0 points. All right, so now you multiply the weight times the points. So the weight times the points, 4 times 4 is 16. 5 times 3 is 15. 3 times 1 is 3. 3 times 2 is 6. 2 times 4 is 8. And now we need to add this. That's what this means. Add the column. So if you add up all these numbers, you're going to get a grand total of 48. And then you also have to add up this column. So that would be 9, 12, 15, 17. And as you can see, the mean or the weighted mean is this number divided by this number, and that represents the GPA. So the GPA is going to be 48 divided by 17, which is
2.8.
2.82,
Yeah.
right? 2.82. So, yeah, that's how you find, it's the same formula. They're just using different letters. F over here represents frequency. Over here, W represents the weight of the grade. And then, and then over here, X representing the midpoint. Over here, X represents the number of points for each grade. And you still multiply them just like you did over here. And then you add them. And then if you divide those two, that's how you get the GPA. All right. Sorry, I rushed through that. I just wanted to make sure that we completed it before time was up. So that is it.